Laker, Scott.
You guys are always welcome to eat your lunch in here, but I do ask that the mess gets cleaned up, right? So if you have a mess, we're gonna clean it up. But we can always eat our lunch in there, because I know the lines, especially for that one station.
I just threw him on board. I didn't know that.
It's like. All right, so we are now 4.7. It is another short lesson. So yesterday we had a really short one. Today we're going to have a really short one. 4.7. So first thing it says is find the exact value in radians. Now, what this means is we're not going to type it in our calculator, although do we have that button on our calculator?
Yeah,
yes,
we sure do.
But we're not using it. We're doing this exactly by hand. Okay? Now, before we get started, there are a couple of new rules that we need to know. When we see this notation, yes, it is the inverse notation, okay? If the number that follows is positive, like this is what I'm talking about. So if the number in the problem is positive, you will draw your triangle in quadrant 1. No matter which one of these it is, if it's a positive number, you're going to draw it in quadrant 1. So I'm going to go ahead and do this problem, and then the next one we'll see is a negative number, and we'll have to talk about that. And here we are. So in quadrant 1, I have an angle. And the sine of the angle, this is the sine. We're going to find the angle. This is the sine. So the sine is opposite over hypotenuse. You're supposed to, at this stage of the game, recognize that triangle.
Oh, yeah.
This angle is
60.
60. Now, the answer to the problem in degrees would be 60. But we're to answer in radians. So 60 is what fraction of 180? It's pi over 9. And the problem is over. That's all there is to it.
That is all there is to it.
Okay, that's it. Huh?
I just think like a regular problem. Regular,
I know.
regular.
Now, here comes the different part. The different part is, now we have a negative number. Okay? So, back up. As long as the number is positive, all of those are going to get drawn in quadrant 1. Period. No, there's only going to be one answer. That's like the inverse notation. That's what is a little bit different from what we did before. When the inverse notation is used, you're going to get one answer. Okay? If you type this in on your calculator, how many answers does it give you? 1. Okay? You get one answer. If the number is negative, this is now for negatives. If it's a negative number, if it's a sine, your triangle will be drawn in quadrant 4. If it's a tangent, it will be drawn in quadrant 4. If it's a cosine, it will be drawn in quadrant 2. Now, first of all, these are not Mrs. Ford's rules. I did not make this up. These are the rules. There is a very clear graphical reason for this, but I don't have time today to get into it. You're going to memorize that if the inverse functions are negative, sine and tangent are going to 4, and cosine is going to 2. All right, so how does that impact me? Well, I'm going to draw this. The sine that is opposite over hypotenuse is negative 1 over 2. So that would make this root 3, and the angle is 30. When you answer the question, though, please don't say 30. Which quadrant is 30 in? 1. So 30 can't be the answer. This is your answer. What angle is that? Negative 30. But it's supposed to be in radians, so it'll be negative pi over 6. So when I'm in quadrant 4, using the inverse notation, your angle is going to be negative whatever, negative 60, negative 45, whatever. Okay? You good with that?
Yeah.
Okay. If you took out, I don't want you to, but if you took out your calculator and you typed in inverse sine negative 1/2, it will say, if you're in degrees, it will say negative 30. If you're in radians, it will say, I don't know what that is, negative 5 point something or whatever. Okay? All right, next. Inverse tangent 1. Now be careful,
Oh,
that's
it's not
a
negative.
positive. So as long as it's positive, it's going to be drawn in quadrant 1. And the tangent is 1/1.
45.
So again, you recognize in degrees it's 45, in radians it is pi over 4. One answer. When this notation is used, one answer. Now, I'm going to do a couple more examples with you because I don't like that. So let's do D. Now wait a second. Just wait 1 second. That's a 0. Think about that. Can I,
Yes.
that would be like 0/1.
Yep.
Can I draw a triangle like that?
No, it's a circle.
I gotta use a circle. You can't draw a triangle because there's no side that is 0, right? I mean, that would not make sense. So we must be somewhere on the circle. So here I go around the circle, 1, 0, 0, 1, negative 1, 0, 0, negative 1, right? That's my circle. And what's cosine again? Cosine is x over r. Now, I'm good with r because I drew my circle with a radius of 1. So I just need to find somewhere where the cosine, or x, where x is 0. Now, there's one answer to the question. So I want you to start where we start, and I want you to go around, and as soon as you hit one, we're done. There are more than one angle on this picture that has a cosine of 0, but we want the first one we come to. So, is this one?
No.
How about this
Yes,
one?
yes.
Yes.
There it is.
Pi over 2.
What angle is that?
Pi over 2.
Pi over 2. Now, if you kept going, would this one down here also have?
Yeah.
But remember, there's only one answer, and you take the first one you come to. Okay? Now, I want to throw one more up here. I did not do a good job when I wrote this.
Curveball.
Yeah. Let me throw this one up here. How about cosine, inverse cosine, negative 1 over root 2. Now that is a negative cosine. So I'm going to draw in quadrant 2 as my triangle. Adjacent is negative 1 and hypotenuse is root 2. So we know in degrees that angle would be 45. What would it be in radians? This angle right here where my finger is, pi over 4. That angle is pi over 4. Now, if you said, oh, then your answer is negative pi over 4. No, you're wrong, because negative pi over 4 would be down here, right?
Yeah.
This is the angle to the question, or the answer to the question. That's the angle. So you want the angle that makes a pi over 4 in quadrant 2. So this angle creates that angle right there. So how could we figure out what this is the answer, Ronan?
180 minus.
Exactly. Only I won't, since I'm doing pi over 4, I won't use 180, I'll use pi. Remember, 180 is pi. So this is pi. So I'm going to do pi minus pi over 4, which is 4/4 minus 1/4. So the answer is 3 pi over 4.
So that's the answer.
That's the answer to the question, 3 pi over 4.
Doesn't matter if it's negative. You don't reverse it. You
No,
can't, you
no,
can't reverse it.
no, remember, we're going for the first angle we can get. So, if I'm down here in quadrant 4, I could get an angle going all around like that, but this one is faster, so I want to go with the smallest one I can get. Okay? If I could go all the way around here like this, but that's more than this is.
Yeah.
So I always want to go with the smallest. All right, let's do one more. Let's do inverse tangent, negative root 3. Okay, so the first thing that beat it a lie spot is that notation and a negative. So I know, because I have it written up here and I'm going to learn it, that I must be drawn in quadrant 4. Opposite over adjacent is root 3 over 1. Which means this angle is 60, but since I'm going down, negative pi over 3, negative 60, negative pi over 3. Okay. So, not too bad, but you gotta know this. Okay? Now, nothing sets me off more than when we have a problem like this and somebody puts it in quadrant 4. No, if the number is positive, it goes in quadrant 1, always. That would go in quadrant 4. You see the difference?
Yeah.
Okay, all right, get your calculators out. Note the directions, part 2. We're going to round to the 10,000, which means what? 4 decimal places. It says be in decimal degrees. So go to mode, make sure you're in degrees. And then we're going to type in exactly what it says. Second tangent, negative 1.43. Did you get negative 55.0349? Make sure you're in degrees.
Yeah, I got that.
Now, look at the problem. Does negative 55 make sense?
Yeah.
Yeah, because it's a negative tangent, it's going down, negative 55, right? All right, next one. Second sine, inverse sine, 0.761. 49.5524. Right there in quadrant 1, right? Just exactly like we would expect. And now we've got trouble in reversing. Because I wish that I had a second secant button, but I don't.
1 over sine.
So before you say anything, I want you just to pause. This says, literally, that the secant of some angle is 1.98. Would you agree that's what the problem says?
Yeah.
I want to find the angle that has a secant of 1.98. So think about those problems that we did where you had to find sine and cosine, you had to find everything. What's the relationship between these two? If the secant is 1.98, then the cosine is 1 over 1.98. Does that make sense to you?
Yeah.
That's how you gotta think about the problem. That's how you gotta think about it. So this says that the cosine is 1 over. You never reciprocal your angle, so you're never gonna do 1 over second cosine. That isn't how it's gonna work ever. You're gonna change the problem to a cosine and then do second cosine. So the answer you come up with should be second cosine 1 divided by 1.98. 59.6653.
That's right.
Yeah.
now we're going to put the calculator down for just a minute. We're gonna need it again for number 4. We're gonna put it down for just a minute, and we're going to evaluate these very complicated looking problems.
Oh, no.
But you are going to discover that they're very, very easy. They just look hard. So, your entire math life, your entire career as a mathematician, you have been taught to work in the parentheses first, correct?
Yeah.
So that's what I'm gonna do. I'm gonna pretend that for now, I'm just gonna erase that. I'm gonna pretend that's not even there. That's a positive number.
Quadrant 1.
So I'm gonna draw my triangle in quadrant 1. The tangent is 1/10. Now take a look at that. Does that make sense to everybody?
Yeah.
I need to label opposite and adjacent, so instead of using the decimal, I'll use the fraction. Right?
Yeah.
Now, what's missing in that picture?
The hypotenuse.
Let's find the hypotenuse.
Love it.
Won't be root 11.
Oh, root.
It'll be root 101,
Yeah.
won't it? Root 101, 101, Pythagorean theorem. Now my picture is complete. What did I want to know about that picture? I want to know the sign.
Root 101.
What's the sign?
Root 101.
1 over root 101, which is root 101 over 101. See how easy that is?
Yeah.
So easy.
So easy.
So,
It's
That's
so
how I do
easy.
the picture.
oh, that's all.
You son of a-
Wait, that's so nice.
All right, now I'm doing secant of the angle whose sine is 2/3. So the first thing you're gonna do, you are not gonna be confused by the secant. You're literally gonna cover it up. And you're gonna draw a picture of this. Which quadrant?
1.
1. And this time, the opposite over hypotenuse is 2 over 3.
Yep.
We're right back where we were a second ago. We need our
Adjacent.
adjacent Pythagorean theorem. Remember, these are A and B, that's C. So what do you get? Root 5?
Opposite.
Now we're ready to answer the question. Well, secant is hypotenuse over adjacent.
Yep.
So the answer will be 3 over root 5, or 3 root 5 over 5. I could do these all day.
It. No problem.
Huh?
All right.
What'd you just say?
No, you're good.
We're done though.
Man, wish you would have, because I wish you would have understood what you said in my ear.
Signs.
You saying those weird things. Chill.
So, first thing Elijah did, guys, first thing Elijah did was say, I don't know about this cosecant stuff, but that means that the sine is 2/3. Because isn't this hypotenuse over opposite?
It is.
So you don't have to do that. You have to on your calculator, but you don't have to do that by hand. You can tell hypotenuse and opposite. Isn't that the same triangle? So this is gonna be root 5 again.
Wiggle.
That is hypotenuse over opposite.
Yes, it is.
2 over.
It's
So I
it's
need
2 root 5 over
tangent.
5.
So 2 over root 5, root 5 over 5.
Damn.
I wish you
All right, see how far you can get with the last one. Now be careful, that's a negative number. So you're gonna wanna draw it appropriately.
Oh, I don't know if I can do this one.
Yes, you can't just believe in
I
yourself.
can't do this one. I know it's in quadrant 4.
Okay, so I know it's in quadrant 4. I also know the sine that is opposite over hypotenuse is 1 over 5.
Yeah.
Pythagorean 1 over 5.
And 2 root 6 is 2 root 6.
So So 25 minus 1, 24. This is gonna be the square root of 24, which is 2 root 6.
That's what I got.
I think you want the cosine. So,
And we want the cosine, 2 root 6 over 5.
yeah. Elijah, he didn't look wrong to my cuz.
Okay, now I erased my stuff. So go back at this moment right now. Don't do number 4 yet. We're gonna type this on the calculator. But I want you to go back to your problem, or your answer to A, and type just the answer in and get the decimal form of that. So you're gonna type in 1 over the square root of 101. So 1 over the square root of 101 is 0.0995.
What? Yep.
I'm typing in my, we're not doing problem 4 yet.
Yeah, yeah.
We're just typing in our answers, because I wanna know what the decimals look like. So what was the answer to B? I can't remember.
3 root 5 over 5.
Or I'm gonna do 3 divided by root 5. That's easier.
That is easy.
So that's 1.3416. And then this one was C.
Thank you.
2 divided by
Bless you.
5.
Bless you.
Divided by 5.
Thank you.
0.89.
0.8944. And
Me and
then
your reason.
square root of 24 divided by
2 root
0.9798.
2.195.
Oh, whoa, I didn't get to
No, I'm joking. I just.
Yeah, let everybody.
All right, now, all I did was, we worked our answers out, we got answers that looked like this. So I typed that into my calculator and got the decimal form. Because now what we're gonna do, last thing today, is we're gonna go back and we're gonna type in the problems in number 3 straight into our calculator. So when I type for problem 3A, sine, second tangent, 0.1,
That was close.
I better get that right there.
I didn't get that. Oh, 'cause I'm in Greek. I didn't get that.
Actually, it shouldn't even matter. You're gonna type sine, second tangent, 0.1.
Oh, I put negative 1 on that.
All
Yeah,
right?
I got that. 0.0. Yeah, I got that.
Now, B. We have to think about this, you guys. B is asking me to type in, find a secant. I do not have a secant button. So what I need to type in is 1 over cosine, second sine 2/3. Because to put a secant into my calculator, it's 1 over cosine. So 1 divided by cosine, second sine, 2 divided by 3. Did you get 1.3416?
Yes,
Yes.
sir. Well, I got it last.
This
He took my
is so
calculator.
cool. All right, now, C is a confusing one.
It is a little.
No, it's not.
We can type tangent. We can't type second cosecant.
1 over 6.
So we type in second, no, not 1 over, we type in second sine 2/3.
Oh, yeah.
We have to change it.
No.
Bang. 0.8944.
So, let's be clear about this, I hope you're listening. You gotta type a straight secant, it's 1 over cosine. If you gotta type an inverse secant or cosecant, you have to rewrite the problem as a inverse sine or an inverse cosine. Okay? The only time you do 1 over is if you're typing in, if it says find the secant or find the cosecant. If it's this, you have to rewrite the problem. All right, let's type that and see if we get the right one. Tangent, second sine, 2 divided by 3. Yep, and then that one's easy. Cosine, second sine, negative. Will match. life is good. I'm not gonna do those last two word problems, we have enough word problems for 4-8. So, 4-7 will be due on Monday.
But